Hey guys, Mr. Wilson here. Today we're looking at surface area of prisms notes. At the end of this video, you should be able to find lateral area and surface area of a prism and explain the difference between the two. And you should be able to determine which surface area to find in a specific problem. All right. A prism is a polyhedron with exactly two congruent parallel faces. Okay, the parallel faces are called bases, and the other faces are called lateral faces. Okay, lateral meaning side. Okay. The altitude of a prism is a perpendicular segment joining the bases. And the height of the prism is the length of the altitude. Okay, so we have a prism here. Look at it, parallel bases, right? In this prism, what shape is the base? Well, if you looked at the sides, there are 6 of them, so it's a hexagon. What shape are the lateral faces? All of them are rectangles. And what is the height of the prism, right? The altitude that connects the two bases, and that's here, 10 centimeters. Okay, so making sure that we can identify that stuff helps us out because we need to know really all that stuff before we can go into finding our areas. Okay, let's talk about our areas. Okay, surface area. Surface area is the area of the exterior surfaces or visible surfaces. Let's say visible. I'll use that quotations just to help me out if I messed up. Okay, there are 2 types of surface areas. Okay, the sum of the areas of the lateral faces only is called the lateral area. The sum of the areas of the lateral areas and the bases is called the surface area. In the example above, to find the lateral area, you need to find the area of the 6 rectangular lateral faces. And to find the surface area, you would need to use your lateral area and add the area of the 2. Okay. All right. It says, let the faces with the blue X's be your bases. We have a rectangular prism here. It says, draw and label a net for this prism and then answer the questions. Okay, and so this is where our last section helps us out. With now being able to visualize that as we look, I'm starting with the side that's on the ground. It's a 7x4 rectangle. 7x4, right? And then we have a base that comes out a little bit. It's a 4x2, right? I'm gonna do that same thing on this side as well. 4x2. Okay, and so now as we look at the other rectangles, it's going to be a 7x2. Have that same thing over here. 7x2, and then we have one that'll go on top, and it'll be a 7x4. Okay, so now let's answer the questions. It says perimeter of the base. So based off of the directions that are beginning, where it says our bases are the ones with the blue X's, we'll call these the bases, right? Could just follow directions. All right, so the perimeter of our base, 4 plus 4, 8, 2 plus 2, 4, 8 plus 4 is 12. Our height, remember they said the distance between our 2 bases, so it's 7 centimeters. Okay. So look at the big rectangle that makes up the middle of your net. What is the length? Well, as we look at this, right, we drew this whole net. We kind of broke it up into little pieces here, but we could look at this big rectangle instead of finding the area of each of these rectangles individually. We could look and say, okay, this is 4 by 2 by 4 by 2, right? And so that's 8, 10, 12. What's its width? Its width is 7. What's this area? 84 centimeters squared. Okay. The area of the rectangle is the area of all the faces except for the bases. So this represents the lateral area. Okay, all the area of all the lateral sides, or lateral faces. Should have said that there. Okay. Okay. I showed you the previous example to demonstrate where the formula for lateral area comes from. Okay. The lateral area of any prism is a product of the perimeter of the base and the height, or the altitude. Okay. Formula, lateral area equals perimeter times height. Okay. The surface area is found by adding the areas of the two bases. So when we look at surface area, you might see this written as perimeter times height plus 2b, where b stands for the area of the base. This shape will change from problem to problem, so finding b will change as well. So let's look at a few examples here. We have a triangular prism. That is 3. Okay. All right, so we have a triangular prism where we have a right triangle as our base. The shape of the base, say right triangle. So they're asking us to find the lateral area and the surface area. Let's do that. In order to find the lateral area, right, our formula for lateral area was the perimeter of our base times the height of our prism. So as we look at this, it is a right triangle, and they gave us two sides, so we can use Pythagorean's theorem to find the third side. This is 3, this is 4. Okay, 3 squared, 9, plus 4 squared, 16 should equal c squared. So we should see c squared is 25. C then will be 5. Okay, so we found that out. The perimeter of our base then is 8 plus 4, 12. The height of our prism is 8 feet. And so we should find the lateral area. Again, that's just all of the lateral faces as 96 feet squared. Our surface area is going to be our lateral area plus our two bases. So surface area equals 96 plus 2b. In this case, we need to find b. B, since this is a triangle, 1/2 base, which is 4, times height, which is 3. So as we multiply that, we find that b is 6. So surface area equals 96 plus 12, which gives us 108 feet squared. Number 2. All right, says this hexagon is regular. This hexagon is regular. All right, and I believe this is the hexagon that we looked at the beginning. Let me make sure. Yep, hexagon that we looked at the beginning. If you were like, hey, what's that surface area? Here we go. All right, so shape of the base, it's a hexagon. I'm actually going to use a different color so that I don't get confused with what I'm writing. All right, so start with our lateral area. Again, it's going to be the area of the, the perimeter of the base times the altitude or the height of the figure. Okay, so it's 4 centimeters on each of the 6 sides. And so 4 times 6 should give us 24. The perimeter of our base is 24. Okay, again, what that does is it gives us basically the base of each of the rectangular sides, and then times the height of each of the rectangular sides should give us all the rectangular area. And that height in this case is 10 centimeters. So our lateral area is going to be 240 centimeters squared. Okay, our surface area equals that lateral area plus 2b. All right, b in this case, probably a little bit more difficult than finding the area of a triangle, right? This is a regular hexagon. And so remember, the area for our regular polygons was 1/2 the apothem times the perimeter. Okay, so the apothem, remember, was the perpendicular distance from the center to the side. Okay, in a hexagon, we had to find that central angle. Okay, and so it's a hexagon where our whole side was 4, and so we'll have this as 2. We can find that central angle by saying 360 divided by the number side 6, which gave us 60. Split that in half, that gave us 30. So we have a 30, 60, 90 triangle, right? Remember, in a 30, 60, 90 triangle, we had our ratios of S, 2S, and S radical 3. Okay, so since we know that S is 2, our height is going to be 2 radical 3. That's our apothem. Okay, and so we have all the information that we need in order to find the area of one of these bases. Apothem is 2 radical 3. Perimeter we already found to be 24. And so the area of this base should be 1/2 times 2, cancels out, 24 radical 3. All right, so now that we know that B is 24 radical 3 for the second problem, we can find our surface area, which is our lateral area, 240, plus 2 times 24 radical 3. And that gives us 240 plus 48 radical 3. And I'm going to write it like that because if there's anything, or centimeters squared, if they asked us to write it as a whole number, or sorry, to the nearest decimal, we'd be able to do that. But if they asked us the exact answer, we have that as well. Okay. All right. Last example here, real world example, where it says an above ground pool is in the shape of a regular octagonal. I'm going to cheat. I'm going to draw a cylinder and just pretend that it's an octagon. That way I can talk about the important stuff. Okay, so here's my cheating octagonal pool, because the important thing for us to know is that we need to understand what material we need to make this the walls of the pool. So as we're thinking about the walls of the pool, we should say, where are the walls? The walls are going to be these sides. Okay, basically, they're asking us to find the lateral area. Okay, and we can do that because they gave us a lot of information. They told us that the pool is 5 feet off the ground on each side. And so that tells us, hey, this height, this altitude must be 5 feet. Okay, they told us that each side of the pool is 8 feet long. So now as we think about it, okay, it's an octagonal pool and each side is 8 feet long. So 8 sides, 8 feet each. Our perimeter is 64. Okay, so the lateral area of this figure is going to be 64 perimeter times 5 height, and that gives us 320 feet squared. We need 320 feet squared of wood to make the walls of the pool, answering this question. Then it says, what is the area of the lining on the inside of the pool? Okay, so we have to get a lining so that the water doesn't just seep through this wooden pool. So how much lining do we need to get? Okay. Now your natural inclination must be like, oh, that's the surface area. Okay, but we're going to have to think past that, right? I know we talked about surface area and lateral area a little bit, but if you think about it, it's a pool. And so what we won't be covering the top, because if we cover the top, we won't be able to enjoy the pool. So we will use for our lining the lateral area, okay, but we won't be using 2 bases, we'll only use 1. Okay, and so our lateral area we already found to be 320. And now the area of our base, let's try that. We're going to have to use a little bit of trig here. This is going to be 4, right? We have 360 divided by 8, which gives us 45, right? And so when we split that, that gives us 22.5 here. Okay, if we're looking for our altitude here, our apothem, then we'll be able to find that by doing opposite over adjacent tangent. So we'll say to find this apothem, tangent 22.5 equals the opposite over the adjacent. So the apothem will equal 4 divided by tangent 22.5. And so we could write that as a value, like we could write it as like 9.66 or something like that, but I would rather us keep it into our calculator as 4 over tangent 22.5 for as long as possible. So that's what we're going to do. Remember, the area of a regular polygon is 1/2 the apothem, which we're just going to write here as 4 over tangent 22.5 times the perimeter, which we already found out was 64. And so when we multiply this through, we're going to get, what do we get? 309.01, 0.02, 29.2 or 0.02. All right, so that is area of prisms, or surface areas of prisms. All right, see ya.